Folks, hello and welcome to your Week 5 discussion post. We have got a lot going on this week in this discussion post, so let's not delay and let's get right at it. Please make sure you have your calculus identification number ready. It looks like we will be using just the B digit from your CIN this week, so have that ready and we'll get ready to go here. This week, again, still talking about differential calculus, and we have an added concept here, this idea of parametric equations. And from your reading, I think you probably have a good idea of what we're talking about here. You know, the example that we're looking at in your discussion post, a spacecraft. Obviously, if you consider that a spacecraft moving and you consider that in two-dimensional space, obviously there's a horizontal and vertical component to that. And this particular spacecraft has movement that is described by these two parametric equations, where your actual parameter here is t, which is being measured in time. So it says in the statement of the problem, a spacecraft moves along a path described by the parametric equations. So you have horizontal movement and you have vertical movement given by those two equations. Before I go any further, as you get into this and you start getting into the calculus of this, make sure you understand that this -1 is not under the radical sign here. So there's not a cancelization under the radical of the 1 and -1. This is outside the radical, and that's important as you start getting into this. So again, spacecraft moves along a path described by these two parametric equations for the first 100 seconds after launch. It says here x and y are measured in meters and t is measured in seconds. Find the magnitude and direction of both the velocity and the resultant acceleration of the spacecraft. 1b, so something in the teens, probably seconds after launch, where you're going to substitute your value of b. Now, I'm going to flip over to a handwritten document because there's a lot of things that I want to. There's a lot of I would say subcomponents to this in order to get this work done, and I sketched this out by hand to make sure I didn't mess anything up in an equation editor, and I hope this is helpful just the same. So starting here in the upper left-hand corner, I wrote the equation of movement in the x direction, and it's 10 times the quantity square root 1 plus t to the 4th power minus 1. And as I reminded you in the statement of the problem, the -1 here is outside of the radical. So there's a problem like this done in your homework, and I'm sure you'll find one in my math lab as well. But here are the steps that we need to go through. So I would, you can consider these position equations, and you know that the first derivative of position actually gives you velocity. So we need velocity in each direction. So you're going to start by taking the velocity, or I'm sorry, the velocity is found by taking the derivative of this function with respect to time. So first step, find the velocity in the x direction by taking the derivative with respect to time of this function, and that is this step right here. Then once you have defined that derivative, you're going to evaluate this derivative at time equals, if say for instance your b value is 4 at 14 seconds, so you'll get a numerical value for velocity. Then you're going to go to the equation of motion in the y direction, 40t to the 3/2 power. Note that only t is being raised to the 3/2 power here. So first step here will be to find the velocity in the y direction, and so you're going to take the derivative of this function, this equation, y with respect to t, and you'll get that in the form of t. And then the next step will be to evaluate the velocity at t equals, again, whatever your value of b is. If it's 4, for example, you'll be substituting 14 for t and finding the velocity in the y direction. Now, it asks for the first thing that you're asked for here, what is the magnitude of your velocity? And this is the magnitude of velocity is defined as the square root of the component velocity squared. So you'll take your velocity in the x direction from above. I won't shuffle back up there so I can kind of keep this steady for a moment. So take the velocity in the x direction and square it, plus the velocity in the y direction and square that. Once you have that sum, you will take the square root, and that will be the magnitude of your velocity the magnitude of velocity. Then you're going to want to know the direction of your velocity, and that once you have again the component velocities in the y and the x direction, the tangent of the angle or the direction of your velocity, the tangent of that angle is equal to the velocity in the y direction over the velocity in the x direction. So typically when we find typically the tangent of an angle, we'll know the angle, we'll punch that into our calculator, and it'll give us some measure of the tangent, which is obviously the ratio of these, in this case, of these two components. Remember now, in this case, you're going to be taking the inverse tangent. So here you're going to want to know the angle itself, not the tangent of the angle, but here you're going to be looking for theta, which is the direction of your velocity. And if anybody has an issue with your calculator, let me know, and I will help you through that. So that will give you all of the velocity measures. Then we're going to go up here, and we're then going to work the acceleration. And this is everything from a procedure standpoint. It's basically the same thing, but now you know that in order to find acceleration, you take the velocity or the derivative of velocity. So the acceleration in the x direction is the derivative of the velocity, which you found over here. So you're going to take the derivative of this function to find acceleration, and to find the acceleration in the x direction, you'll evaluate this function at t equals whatever. Again, if your b value is 4 at 14 seconds, and then you'll go back and find the acceleration in the y direction. That's found by taking the derivative of the velocity in the y direction. That will be the derivative of this function with respect to t. And then similarly, to find the acceleration, the numerical acceleration, you'll be substituting t equals, again, whatever your value of b is. If it's 4, it's 14 seconds in flight. And then, again, the very same way that we found the magnitude of velocity, you will find the magnitude of acceleration by taking the acceleration in the x direction and squaring it, plus the acceleration in the y direction and squaring it. Once you take the square root, that will be your magnitude of acceleration. And then finally, one final step here to find the direction of acceleration. Again, you're looking for this angle, and so you'll take the inverse tangent of the acceleration in the y direction over the acceleration in the x direction. So I know there's a lot going on here, but I especially hope that this template helps you keep things in order. And this is something that I would consider to be methodical in the sense that it gets you to the points where you can find magnitude and direction very succinctly and present it very clearly. So let me just go back here and close this out by saying, as a reminder, for your rubric, again, your initial post on the board, it should be your very best attempt. And again, if you address this using the template that we've discussed here, you'll be in good shape. If there's anything that we need to get cleaned up on this, I will send you a note within 24 hours. Please address my comments and then repost. And then probably the most difficult thing this week is navigating the equation editor. There's a lot to do here, so you just got to be deliberate here, be very careful. Probably best if you if you want to take and just kind of scratch it out by hand. That's probably the best thing to do, and then you can go back and then you can put in an equation editor and post everything to the board that way. I think that is probably a pretty good idea. So again, a lot to step through this week. Be careful as you go through it. I hope the template is helpful, and I look forward to seeing your posts on the board. If there's anything I can do for you, please let me know. Otherwise, have a great week, and I look forward to seeing all the great work on the board. Take care.